So we've done systems by graphing. How do you solve a system by graphing?
Put the numbers in the graph.
You put them into slope-intercept form, graph it, and where's the solution? Where they cross. We've done system substitution. And how would you solve systems by substitution?
Replacing whatever that is.
Plugging things in. We're substituting, right? So you're graphing to solve by graphing. You're substituting to solve by substitution. And now we're going to talk about elimination. What does it mean to eliminate something? Get rid of something. So we're doing exactly what it says. We are eliminating a variable in order to solve. So on the left here is a solved out system. I'm not going to go through this system, but we are going to look through the steps. Okay, we're going to use those steps with example 2. So first things first, you have to line up your variables vertically. Kind of like if you had, when you were learning how to add decimals. How would I add those? Right, I would line them up. I have to line them up. So I'm going to have the same idea going here, but instead of lining up decimals, I'm lining up variables. So, example 2, it looks as if maybe they're lined up, but they're not, right? Y over X, X over Y. So what I want you guys to do right now is convert both of these to standard form. If you don't remember what standard form is, that's AX plus BY equals C, which is also going to be on that test 2-3, because remember it was on 2-1. So that's something, if you don't remember, we need to go back and look at. Okay, my first equation in standard form, what is it?
6x plus 3y.
Very good. 6x plus 3y equals 24. My second equation, love it. Okay, so I've lined my variables up. My second step says manipulate your equation so that one of your variables will cancel out. Then you add your equations together. So I'm going to be adding down, just like what we talked about with those decimals. But I want one of the variables to eliminate when I add. And right now, nothing is going to eliminate. I would get 10x and 6y. Is there anything that I could do to one or more or both of these equations to cancel one of these variables out? Okay, multiply by -1. What would that do?
It will make the 3's cancel out.
Very good. If I multiply one of these equations, doesn't matter which, by -1, that y will cancel out. So if I say, okay, let's multiply this by -1, I get -4x plus 3y, nope, plus, thank you, minus 3y is equal to -18. And I'm going to bring this other one back over 6x plus 3y equals 24, and I'm going to add them together. We're always adding. So, -4x and 6x, 2x, -3y and 3y cancels, -18 and 24, 6. So 2x equals 6. Divide by 2. So x equals 3.
Yeah, so you never use the y in this?
Yeah, sometimes you are going to cancel out a different, but it's always about which one is easily set up for us to cancel. There are going to be some scenarios where we're doing the opposite. Yes, Colin.
So basically, how would you do it if it was 6x, 6x plus 3y, and like 4x plus 7y?
We'll talk about that at the end, on how you would do if it does it. That's a very good question. Yeah, how it would work if nothing is really set up nicely, it's still possible.
What if I like a negative?
Not necessarily a decimal, but you can multiply both equations. It's kind of like getting common denominators, right? So getting something, but manipulating both in order to get there. Yes.
If you were to not do that, times -1 would be a value, or did you have to do that?
I have to do that to one of them. I could have done it to the other, and it would have worked, but if I would have just added straight down, nothing would be eliminated. So you would still have two variables.
Oh, if you're trying to get it.
Exactly. Because now, my last step is same for substitution and elimination. I'm going to take this, and I'm going to plug it back in to one of my equations. So I guess let's do this one, right? So 3y equals 24 minus 6, and now we know x is 3. So 24 minus 18, which is 6. So 3y equals 6 plus you what's y? 2. So my solution is 3, 2 plus you. Okay. All right, go ahead and flip over. We're going to try another one together, and I'm going to let you guys try one on your own. We're going to do number 2 together. What variable, it's already lined up, right? So some of my work is already done. What variable, when you look at that equation, do you guys want to cancel out? The y? Good. You could have done the x, but you can do the y as well. What do I have to do in order to cancel out that y? Multiply one of the equations by -1. Doesn't matter which one. Which one are y'all thinking? The first one. You could have done the second one. I like the idea of the first one as well, just because now I've got more positive values than I have negative, so it will end up being a little bit more friendly as I work through. So that would be positive 2x minus 6y equals 26, and my other equation remains the same, 8x plus 6y equals -16, and I'm set to add down. 2x and 8x, 10x, -6y and 6y, cancel, 26 and -16, 10, so what's x? 1. So let's plug it back in, -2 times 1 plus 6y equals -26. So -2 times 1, -2, add it to the other side. So 6y equals -24. So what's y? -4. So my solution is what? 1, -4.
1, -4.
Yep. Y'all do number 1.
Oh.
Okay. So all we've done so far is multiply by -1.
Did you go over that?
Yep. It's already ready, right? So this would give me 6x. That cancels, equals 60. Nope. 54. Good talk. 54. Divide by 6. X equals 9.
Yeah.
Okay. Now, 2 times 9 minus 3y equals 12. So 18 minus 3y equals 12. Minus 18. -3y equals -6. And then divide by -3.
Oh, I see. I did it up to this market. 2 times 9.
There you go. Okay, now, look at this system. 2x, 4x, y, and 3y. Can I just multiply by -1 to get rid of those? No, because I've got a 2 and I've got a 4, I've got a 1, I've got a 3. So I have to not only multiply something by a negative 1, but something has to get multiplied to change the value itself. Column. Negative 3. So what variable will you be canceling out if you multiply by negative 3? The y. Okay, I could have also eliminated the x, right? I could have, because I've got 2x and 4x and 2 goes into 4. So I could have made the x's disappear as well. It doesn't matter, right? So if I'm going to cancel out y, I have to multiply which equation? The top one, because I need 3 to cancel out, so I need negative 3y. What do I need to multiply by to get that? Negative 3. So now, I'm going to bring it down here, because I'm going to multiply by negative 3. I've got negative 6x minus 3y equals negative 24. Every single value needs to multiply by negative 3. Nothing on your second equation is going to change. I've got 4x plus 3y equals 18. Now am I set to add? Yes. Negative 6x and 4x. Negative 2x. Negative 24 and 18. Negative 6. X is 3. So x is 3. Let's plug 3 back in. So 2 times 3 plus y equals 8. 6 plus y equals 8. What's y? 2. So what's my solution? 3, 2. Okay. Let's do one more like that together. We're going to do number, I'll pick one out. 4. I heard 4 first. Same thing as last time. Okay. I heard 4 first. X plus y equals 12, 2x plus 3y equals 31. This is another scenario where it does not matter which variable you're going to cancel. Which one? Okay, I heard x first. If I want to cancel out negative 2, which one? Top. So I've got negative 2x minus 2y equals negative 24. So let's add. 2x and negative 2x, gone. 3y and negative 2y, y. 31 and negative 24, 7. Very good. So y equals 7. Okay.
Off by 1.
Or 5.
X is 5. Because if x plus y equals 12, that would be the easiest one to just plug that into. So what's my solution? 5, 7.
How would you put that?
X plus 7 equals 12. Subtract 7. Okay. Y'all do 2 and 3. Number 2, what'd you get?
Negative 1.
Negative 1 what?
5.
Okay. What about number 3?
10. 1.
10, 1. Okay. Now, special cases. We've talked about special cases for all the different systems. What would I mean by special cases?
No solution.
Infinite and no solutions. Okay, so y'all already know what's coming here. Looking at situation 1, everything is lined up. What do y'all want to eliminate? Y. Okay, it doesn't matter. I heard y first. If I'm eliminating y, what do I need to do? Multiply by negative 1. Doesn't matter which one. I'll do the first one. Negative 1. So negative 2x minus 3y equals negative 9. 2x minus 2x? Cancels. 3y minus 3y? Cancels out. What's left on that side of the equation?
9.
On the left side.
Not zero.
0. 5 minus 9, -4. What's wrong with that?
No solution.
It's not true, so there is no solution. That's from the beginning. We're gonna have to go back. Okay, situation 2. Do I need to line anything up? No, it's already lined up. Do I need to multiply? No, it's already set to eliminate. What's going to eliminate? Everything. So what's left on the left-hand side? What's left on the right-hand side? Infinite. So that is true. Okay, infinite solution. Now, when we got down to the end of each one of those scenarios, how were they different?
One is on the right side that had number one.
Okay, so one was not equal, and the other one was equal. Right? So we can say if the outcome is a true statement, what's my answer? Infinite. If my outcome is a false statement, it's no solution. Okay. So, Colin, now I'm going to address that question that you asked. What happens? This is not on your paper, so you can just write it on the bottom corner of your homework, maybe the bottom right. -7x minus 8y equals 9, and -4x plus 9y equals -22. The only thing going for us here is that they're lined up. But there is nothing that I can do easily to get 4 to 7 or to get 8 to 9. Right? Let's find, well, not a common denominator, but a common factor. Okay? So what's common? This one is -8 and 9, 72. Is that, I'm not really wanting to deal with 72 as my value. What's common between 7 and 4? 28, right? So 28 seems a little bit more manageable than 72. That doesn't mean that you can't use 72, but let's get these, one of them to be positive 28, one of them to be negative 28.
Multiply 1 by -4. Multiply 1 by
Or we'll find the other one by that.
Okay, so let's make this one the opposite so we can get this to be a positive value. So let's get 22 to be positive. So -7, and then what would I multiply the top one by? +4, right? Because then this is going to give me -28x, and this one's going to give me +28x, right? And that's going to set me up to cancel. But let's do the rest. So if I multiply -8y by 4, what am I going to get?
32.
-32y. And 9 by 4? 36. Okay, so let's do the second one. -7 and 9y. -63y. Okay. -22 and -7.
80.
154. Okay, so now this is one of those cases I can still eliminate, but there wasn't just a simple change here. I had to multiply both. So now I'm going to eliminate x. -32 and -63, -95y, 36 and 154, 190. Those numbers seem huge, but 190 divided by -95 is -2. So all of that and y is -2. Okay? So you're having to do a lot of work. You're having to get a common factor, but you still got there. Okay? So it is possible to multiply both equations. Bless you. All right. Now, it is 10:26. I'm going to get y'all's tests marked up so you can see what you missed. Get those back to you. You have about 10 minutes to work on your homework. So it's like 1,000 times more than first period.